One of the things we're going to look at next is another way in which we can do confidence intervals by using either the TI-83 or the TI-84 calculator. And both of these contain exactly the same style of input. The first thing we would want to do, especially the way that this problem was written, is we were actually given the raw data. So you'd want to take the time to go ahead and do some data entry and put these in L1 list of your calculator. It's been some time since we've done this. Let me just kind of remind you how this would work. You would go to the stat menu, go ahead and hit edit to enter, and then all of these numbers would go in a single list. I put them all under list L1. From there, we're going to do a brand new command. This is going to be stat. We're going to go over to tests, and if you scroll down, there should be an option for what's called the Z interval. Okay. Again, we're trying to do an interval estimate for a population right now, and if you go down to where our formula for the margin of error was, the margin of error in 6.1, because we had a large sample size, it was 32, that meant we were using a Z-score, which will correspond to a Z interval. So we're going to use the Z interval command. This particular command allows us to do two different styles of input. Okay? So if we had, let's say, the summary statistics, in other words, if they didn't give us the 32 values, but if they gave us the highlights, then you would go ahead and use the stats button. And you would need to toggle it over to hit enter so that it would stay solid and be selected. However, we actually had the raw data set. We actually had the 32 values of the people that drove to work in Horry County. So we want to work off of the data option. So I'm going to go ahead and hit enter for the data. We know from our calculation, either by doing a one variable stat or looking at what they told us in the notes, that standard deviation was 7.098. We're going to use the list L1, that's where our data was stored. We only entered each value one time, so you always want the frequency to show up as 1 in your Z interval command. And then the last thing they're going to ask us for is what level of confidence do we want to construct our interval for. For this particular example, when we were doing example 1, we were constructing a 90% confidence interval. So the C level as a decimal is going to be 0.90. If we go ahead and hit calculate, this is what the calculator will give us. It'll tell us the interval. This was our confidence interval right here, which we can go ahead and double check. To two places, it's going to be 7.37 and 11.50. That includes a little bit of round off error because some of the values that we used in our calculation were rounded. The answer you will get from the calculator will be a little bit more accurate in the sense that they will float all of the digits and maintain it all the way down to the nearest accuracy. Like for example, if we look at our standard deviation, we rounded our standard deviation to 7.098. They would take theirs out a little bit further. Let's do another example of this. In example 2, we're going to construct two different confidence intervals. We're going to do one for 90% and another for the 95% confidence interval for the population mean in the following situation. Suppose we take a random sample of 48 days in a year. That 48 will become extremely important because that's more than 30 or more. So that means we will be able to do a Z interval ultimately. They tell us that in this sample of 48 days, gasoline prices had a mean of $2.34 and a standard deviation of 0.32. Let's go through first and calculate the 90% confidence interval. I'll do this both by hand and then we'll use the calculator, and then we'll go ahead and we'll do the calculator to construct the 95% confidence interval. So we already have X bar, we have S. The only other thing in addition to X bar that we're going to need in order to do our interval estimate is we need the margin of error. So we need that number E. If you go back to the formula, E is equal to ZC times sigma divided by the square root of n. Well, we have sigma, or S we can use as a stand-in right now, that's 0.32. We know the sample size was 48, so we have that. The only thing that we don't have at the moment is the ZC value that corresponds to a 90% confidence interval. If you were to sketch out your bell-shaped curve, we know that 90% would be in between those two Z critical values, which means that 10% would lie on the outside, and then half of the 10% would be 0.05. So to find the Z critical value, we're going to do an inverse norm. The area to the left would be 0.05. It's a Z-score, so mean of 0, standard deviation of 1. And to 3 decimal places, we would get negative 1.645. But for Z critical, remember, it should be positive. So we're just going to switch it and make it a positive 1.645. Once we have that, we can compute the margin of error. It's ZC times sigma divided by the square root of n. That's going to be 0.08. That's our margin of error. We can now go ahead and complete the confidence interval. It's x bar minus e to x bar plus e. Our sample mean was 2.34. Our margin of error is 0.08. So we get as our interval estimate 2.34 minus 0.08 to 2.34 plus 0.08, which gives us a 90% confidence interval of 2.26 to 2.42. So our conclusion would be that we are 90% confident that the true population mean would lie somewhere between $2.26 per gallon and $2.42 per gallon. Let's rework the same problem, but let's now do a 95% confidence interval instead. And we have most of the information we need. The only thing that we don't have would be the Z critical here. And actually, I'm sorry, before we do that, let's go ahead and do this with the calculator. Let's go back to the 90% one. If you wanted to construct the 90% confidence interval using the calculator, you would go to the stat menu. This is under the test menu. And right now we're doing an interval with Z scores. So we would be doing Z interval. Hit enter. The difference between example 2 and example 1 is that in example 1 we had that raw data, so we needed to work off of the data ribbon. Here they don't tell us the values of all 48 prices at gas stations. They just give us the summary statistics. So we need to work off of the stats ribbon. I move the cursor over, I highlight stats, hit enter. When you use this kind of input, they want to just ask you these 4 values. What is the standard deviation? Well, for this example, it was 0.32. The sample mean was told to us. That was $2.34. Our sample size was 48, so that's n. And again, we need to put in the confidence level. For the last example, we did 90% confidence, so that's 0.90. Go ahead and hit calculate, and we see that it would perfectly match up to 2 decimal places, or to the nearest cent. It's $2.26 to $2.42. Now let's go ahead and do the 95% confidence interval. We have almost essentially everything we would need if you were to do it by hand, with the exception of that Z critical value. And again, when you do the confidence intervals by hand, it's the Z critical that oftentimes requires the most work, but it's always going to be the same kind of process. You do 1 minus C divided by 2. That'll give you the cumulative area in the left tail, which will allow you to find the negative Z score of negative Z critical, and then just switch the sign. So if I at least wanted to show that portion of it, okay, I could do second distribution, go to inverse norm. For 95% confidence interval, it would be 5% on the outside, which would be the 2 tails. Half of 5% would be 2.5%, or as a decimal, 0.025. And what we would see is that corresponding to a 95% level of confidence, that would be a Z score of, Z critical of 1.9 round to 60. However, now that you know how to do the z interval command, you can simply go ahead and use this for any problem that asks for a interval estimate. I'm going to go to stat, over to tests, go down to option 7. We were again given the summary statistics, so I'm going to work off of stats. For this problem, same standard deviation, mean. The only thing that's changing is we're moving our confidence level from 90% up to the 95% confidence level. If we go ahead and hit calculate, we would see that at the 95% confidence level, our interval is going to be 2.25 to 2.43 to the nearest penny. So 2.25 to 2.43. One of the takeaways and the comparisons that we want to make as it pertains to confidence intervals that we briefly touched on before is we would want to understand how does the confidence level affect the width and the size of the interval. And the answer is just kind of if you graph these two intervals on the same axes, what you would see is that the 95% confidence interval would actually be wider than the 90% confidence interval. So essentially what's happening is as your level of confidence increases, the interval itself becomes wider. I always like to kind of use the analogy in class. If you're to try and, let's say, catch a fish. So if you were in like a stream or a lake and somebody asked you, okay, here's a net. Can you catch this fish in the net? Ask yourself the question, would you feel more confident with a smaller net or more confident with a larger net? Obviously, the larger the net, the more confidence and the more room for error you have. So the more confident you want to be, the wider your confidence interval has to be.